Let's look at Rust. Rust is really important because it fixes the major security flaws in C, which are really drastic and have caused many serious security vulnerabilities. The problem with C is it is subject to memory corruption because it's really too close to assembly language. When you make an object in C, it is not really what you think it is, and it confuses developers. So anyway, let me start with this R10. And so first you have to install Rust, which is much easier than what we did with Go, because they just do something sort of unprofessional. You download source code and then execute it with curl. So they change the source code on the server, and you're totally trusting them. You don't verify a hash or anything. But if you do these commands, it will create Rust code easily. And so I tested it earlier, and it worked fine. So if I look at my source code here, there we are. This is what my Rust code looks like. Let me get rid of the colors. So it's again similar to Go and similar to Python. I just have a print that says hello here. And so that part is not too surprising. And you compile it with Rust C, and then it creates hello. One thing, by the way, that is a little disturbing is that if the compiled code is very big, and that's why I thought Rust was extremely inefficient compared to C, but what I read in forums after I prepared these lessons is by default, Rust compiles everything with debug information, which makes it big. And there is a switch someplace to turn that off, and they say after that it is as efficient as C. But what we're going to see, the reason Rust exists is it is much safer than C, and that's why Microsoft is thinking of writing part of their operating system in Rust, and other people are developing a lot of software in Rust because it doesn't make as many mistakes. And so, let's see here, here's integer data types. So if I make this, I'm just going to handle some integer arithmetic in Rust. So this code just creates an object. Now, when you create an object in Rust, you tell it what type of object it is. So this is an unsigned integer, 32 bits long. So I'll put that in. So I set I equal to 1 without telling it what it is, and I set j to be an unsigned integer. And so if I run that, Rust C, it's going to tell me something's wrong. And it's going to tell me you cannot set an unsigned integer to a negative number. Unsigned means unsigned, right? There's no such thing as -5 in unsigned. So you can fix that. And then let's add numbers, because we're going to quickly see why Rust is better than C, which is the point of this. So let me go here. All right. Then we put in this stuff. All right, so here I have a equals 1, and then I set a equals a plus 1, and see what I should get. So if I run that, Rust C, add, again it's going to complain. All right, first assignment to A, and you cannot change it because it's an immutable variable. So there's a link here to read about variables. There are variables that are not allowed to change. They are immutable, and there are other variables that are allowed to change. Anyway, but the interesting point is that it doesn't have these overflows. So let's make a C program and compare it to a Rust program. So here's an overflow. Let me see where I am. I seem to be somewhere funny. All right, I'm going to go back to my home directory. All right, so here's my overflow in C. This is the standard way you make a C program. You define an integer, I, and you define an unsigned character, x equals 230. Now, this is what I mentioned when we're doing the Python lesson. I had a lot of really bad habits left over from C and Python 2.7. And one of them is thinking that an integer is the same thing as a character, because they are. So I can define a character equal to 230, and then I can just add numbers to it, because it's just a number. And you can totally get away with this in C. It is a terrible thing to do, though, as we're going to see. So 10 times I'm going to add to it. I'm going to add 1, then I'm going to add 2, then I'm going to add 3. So I'm just going to get a series of increasing numbers in that variable. So if I run this This creates an integer overflow. I had 200 and something. I went at 231, 233, 236. And then when you add more, it rolls around and turns into 2. So if you look at the source code, this is why there are so many security problems in C. Your developer is trying to do something. Let me make this bigger. All right. And they make a variable called 230, and then they add numbers to it. And it suddenly stops getting bigger and gets small again. Now, how are they supposed to understand this? Why do you expect a developer to remember and understand this? This is insane. This would not happen in Python. It would not happen in Visual Basic. This is a problem with C. When you define the variable, you're supposed to know that this is stored as an unsigned 8-bit number, and that when it rolls past 255, it will wrap around. And all that crazy stuff that the developer is supposed to remember is what leads to so many security problems, and this is the first one, that when you add numbers to an integer to make it bigger, it gets smaller instead, which, some of us have gotten used to doing this in C, but when you think it over, you think, that's actually insane. Why would you do that to a poor developer? Why would you let them think that when you add another positive number to it, it will get smaller? So that's the first thing. And that will not happen in Rust. This is the whole point of Rust is it gets rid of many of these traps that cause all the security problems. So that's one of them. So here we write the same program in Rust, and when you do, you have to tell it what the variable is. And if you tell it that that is an unsigned 8-bit variable, which is what I wanted, using character, equal to 230, and then I add numbers to it, it's not going to do that to me. So when I compile that and run it, then what happens is it adds up, and when you try to make it bigger than 255, it gives you an error saying you can't do it. It doesn't just give me the wrong number and keep going, which is what causes the security disasters. It tells me you overflowed what that variable can hold, which is a lot better. Now the developer will know something is wrong, and they'll fix the program instead of creating a program. That's right, and that's right, exactly. I agree with you. You could say the programmer doesn't understand their language well enough, but I think a more practical solution is to say you gave the programmer a language with a bunch of holes to fall into, and you could have given them a friendlier language.
I would say this, is that the language of C is extremely powerful.
Yeah.
And with that power comes great responsibility.
Well, yes.
The fact that you have to be paying attention to what the heck you're doing.
Yeah.
And if it falls into a hole, it's because you, as the programmer, didn't look for it. Because with a lot of the other languages, the stuff that they're doing to quote-unquote protect you is also what limits you from getting to the places that you need to go.
Yes, and this is a real important discussion. For example, the discussion between like Android and iPhone. If you have Android, you can get apps that are not from the Google App Store, but just from anywhere and put them on your phone, and they're often malicious. If you get an iPhone, you can only run apps from the official store, and they're clean. So the question is, do you want more freedom or do you want more safety? Anyway, a lot of people seem to find Rust is their choice, favorite way to avoid this stuff. That gives them enough freedom and yet not as many pitfalls. So let's do a string overflow in C. So I'm going to store 2 strings. All right. So I'm going to just store a string. This has 4 A's and this one has 4 B's, and both of them only have enough storage for 5 characters. So I'm just going to print where they store, read in a new value for one of them, and then print what they are again. This is in C. And so if I run this one, okay, so enter new value for string 2. If I put in a 1 in string 2, now the first string is stored here at address DB, and the next one at D6. So string 2 is before string 1, and it's only about 6 bytes away. If I put a different value, a short value in for string 2, then it works. Both addresses are still stored at the same place, but I changed string 2 to a 1. It was BBB, now it's 1. But of course, if I put in a longer value, like maybe 10 C's, then string 1 has now changed to 5 C's. I entered the data into string 2. String 2 now contains data that is longer than it's allowed to store, but it did not move either string. it continued to put this one 6 bytes before that one. So after the first 6 characters, some of these characters rolled over and changed the other one. And again, I invite you to have sympathy on the poor programmer. They have 2 variables. You enter data in one variable, and it changes the data in the other variable without telling you anything. This is cruelty. In the same vein, that's the kind of trap that could ruin your whole day. And of course, that also does not happen in Rust. So, if you make the same program in Rust, it looks like this. You define 2 string variables, you initialize them as 4 characters each, and I'll just print out the addresses, let you read in a new version for one of them, and let's see how it works. If you run it with the Rust compiler, then it gives you a warning, but it doesn't but you can still run it. So if I give it a new value for string 1, it changes, it adds it to the end. It doesn't replace the existing, it adds it to the end of the string, but that's not bad. And so if I add a whole lot more to the end, it just does what you expect. It adds that to this one and doesn't change the other. And it doesn't move either of them either, but if you look at them in a debugger, you can see what happened. This is not where the data is stored. These are pointers to where the data is stored. And if you make the string longer, it will reallocate more memory to it. And yeah. Anyway, so you can use GDB to examine the stored strings and see those are addresses. And it actually moved one of the addresses when a string got longer, which is what it should do. And this is what Visual Basic would do and most languages would do. If you have room for 4 characters and then you put in 20, it will just set aside more room in a good place to store 20. It won't just run over and ram into the next variable the way C would.
Okay, but I will say this, is when that's actually stored in memory, okay, when you store it as an object, as opposed to direct memory access, if you were cross between trying to be extremely efficient, you can't just go up through memory because you can't just use pointers, et cetera, directly.
No, I think
And with C, you can do that.
Yes.
And I mean, automatically overflowing limits is to me, as a, maybe I should say from an assembly language, machine language, when you go and start doing that, you're writing bad code. And as a programmer, you're not paying attention to what you're doing, and the overhead that the compiler has to do to make amends for your mistakes is that you're adding extra overhead. Now, mind you, not all programmers need that kind of control.
Yeah.
But it is something that you should pay attention to.
Yeah, see, this is very interesting. I mean, I know in C,
and with a lot of languages, when it takes care of that for you, it's encouraging you to, I mean, like if you have a car that constantly goes beep beep to tell you that you might run in or back into something, that's really nice, but that doesn't mean that you should be in the habit of never looking in your rear view mirror to see if anything's there.
Yeah, and the thing is, I remember when I learned C and when I learned assembly, there were all these clever tricks that involved running over to the next byte and stuff. There's all these beautiful, clever mathematical tricks you can do when you work right at the binary level, and you can't do that stuff in Rust, of course. So you're further from assembly language, like you would be in Visual Basic, but what's happening is the objects you create are more like what a normal person would think they would be. So, you could say this is like having training wheels or boxing gloves on. It's you define a variable.
You're implying I'm not normal.
Yeah. Well, I don't know about that. I'm just thinking this. There's two different kinds. There's developers like in assembler, you totally refer right to the hardware, but in these higher languages, you define something like a variable or a string, and you would like to imagine that it doesn't. You'd like to imagine, that string is what a normal person would imagine a string is. Yeah, that's right. Anyway, C will still exist. That's why the first proposal was to totally replace Windows at Rust, and people complained. I think with complaints like this, and now they're thinking of strategically changing things. Anyway, I see Irvin's here. After this, we'll talk to Irvin because people were asking me about how to teach high school students, and Irvin is the expert at teaching high school students. So anyway, let me just, the command injection, by the way, which we had before, where you can actually add an extra command in a line, it still happens in Rust. That one you cannot prevent. And I think that's as much as I had in this one. I think that's really enough to show you the basic issue of how Rust prevents the major memory overflows in C. I'm going to stop this one and hand it over to Irvin, because I think there were several people that wanted to talk about high school students here.